absorption column or the specialized separation operations. Let me admit the last one is Fahad Khan. Okay, so I hope now things are a little bit better. Okay, so now once again we are targeting our special operations. Let's do it again. So very quickly, I already explained that we have to select some components. So my target is to absorb CO2 from water, and here we have Peng Robinson. Actually, we have a specialized kind of absorption absorbent fluid packages for a special kind of absorbents, but here we are using Peng Robinson, and now we are entering in our simulation. We create two streams. So one is a case in stream. It's we say it's some temperature, some pressure, some mass flow rate, and its composition. We say 85% is the air. In this, 15% is CO2. So this is our case. This is our case in which CO2 is in a higher concentration. We have to reduce this concentration at our desired level. And here we are using water as an absorbent. So we are saying this is absorbent, and we have some temperature, some pressure, some mass flow rate, and some composition. Sorry, some composition. Okay. So, so we have completely defined two streams. Now, we have already discussed the simple separation operations like flash separator or three-phase separator. From distillation and onward, these operations are specialized operations and could not be converged easily. Today, at this in this tutorial, we are particularly interested to see how absorbent column is to be converged. So we have to insert absorber column. Now remember, I have already discussed with you that these operations are not simple one. When you drag and drop these operations and when you double click, then you will see a different kind of approach. Instead of direct pen page, you will find some preliminary pages appear in front of you. Like in the absorption column, you are watching the first page of three, means total three pages you will see, and when you defined on these three pages some preliminary things, then you will see the true property panel of this absorption column. So this is the first type, first time come, and when you defined all three pages correctly, then you will not see these kind of things again. So in the first page of this absorption column, you need to define your streams. At least your absorbent stream is mandatory, your gas inlet stream is mandatory, or bottom stage inlet is mandatory, and two more streams are required, which are not optional. These are mandatory, like gas out and I said absorbent out. Now, a few other things are there. For example, these are the optional streams, and this column is usually in a stage fashion, but we can convert this in a packed bed as well. But by default, it is number of stage column. And by default, there are 10 stages. We can increase or decrease the number of stages. But after defining these four preliminary things, you can move in the next page. So when you click on next, you will see this page. So this is top pressure and bottom pressure. Okay, because we have given both streams 200 kilopascals. So I am giving almost same pressure. Though in the top stage there is a low pressure. Now, this is a third page, which is said optional temperature. So it means if you know the temperature information, then you can provide. Otherwise, you can leave this page as empty and done. Now you will see this is now the real property panel. Now, if you close this and again double click on the absorption column, you will not see those three pages. You will see now this only. Now here we have defined each and everything for the absorption column, and these operations are not converged by itself, but you need to press the run button, like distillation column, like liquid liquid section. All these operations need to be converged by pressing the run. If everything is okay, then you will find green symbol here or status here, and it says convert. So you click on run, you will see that it is converged with the only 4 iterations. But if you see some iterations going on beyond 9,999, it will the message will come that the at the provided conditions the column is could not be converted. Okay, so this is converged. Now what happened? Let me see whether we got the things as we thought or not. In the gas inlet, we have a 15% CO2, but at gas out, if we see the composition, you will find that CO2 is 14%, but actually this 14% is not because some CO2 is gone in H2O. But actually, because this air at these temperature and pressures have some affinity to catch the moisture or water. So actually, water is picked by air, and because of the 6% moisture entry, you will find some decrease amount of CO2 in the air, but this is not the decrease. You can confirm that in water outlet there is no any CO2, very minute CO2. You may find 0.0001, means if we convert in a percentage, this is 0.01%. So this is almost look like 0% CO2. So no any CO2 absorbed in this water. Any reason? Anyone can discuss the reason? Yes. Anyone? जी काशू साहब.
Not particularly that. Maybe uh, you mean the CO2 is not absorbed by water, right? That's what we are discussing.
Okay. That's one reason that CO2 is not a good absorbent of water is not a good absorbent for CO2. But in literature and in it is said that water could CO2 could be absorbed in a water at some level. But at least you can find some. Okay, what we need to do to have more absorbance at present condition? Any idea?
Maybe increase the pressure?
Increase the
सर
pressure of what?
इसका जो कांटेक्ट
Water.
एरिया
Uh,
सर
okay.
मे बी वी कैन इंक्रीज द कॉन्टेक्टिंग एरिया, तो उसकी वजह से भी हम लोग इसका जो कनेक्शन है, ये जो आपकी ट्रे की जो हाइट है N10 जिस पे आप स्पेसिफाई हुआ हुआ, जब हम इसका
Okay.
एरिया बढ़ा देंगे तो सरफेस
For
एरिया ऑफ
example,
कांटेक्ट
for
ज्यादा हो
example,
जाएगा.
if we are saying this at 10 and we are converting it 20 and reconvert, so it says okay, okay, some okay, 20. Now we have increased the number of stages, means more we have provided more contact area or more contact uh, surface. So if we see that almost 14%, little bit increase, slightly, but you will not find anything more interested in the composition of water. Now let me show you what is happening. That gas is in the form of kilogram. 100 kilogram gas is there per hour, and total absorbent is 500. if I increase this 500 to 5,000, so it means now I am increasing much water as compared to the gas. Now, is there any difference? Is there any increase? No increase. Now 5,000. If I increase 50,000, is there anything had happened with the situation? Okay, and even more than 50,000, 5 lakhs. Okay, so what is happening? No any CO2 is coming in this, and okay, you will not find any CO2 if you increase the uh, amount, but you will not find any CO2 uh, in the outlet of water. But here, interesting fact is there that CO2 is almost in a 0% of gas entry, and you will have 93% pure air and 6% water. So what had happened? Why we are not getting any quantity which is showing which is being shown here? Okay, let me clear one thing to you. Maybe you may surprise. So ये बात मैं आपको यहाँ से एक चीज दिखा दूं. When you open an Excel and uh, I'm opening Excel and the new sheet. Okay, I'm now copying the value of CO2, which is showing in the 4 decimal places 00. When I copy this in the Excel, so you will find it is not actually 00. It is 4, 5 places 0. Then some values are there. So Excel shows the full length of this variable, almost 16 digits. So it means now who can explain me? This is a more than beyond the chemical engineering. This is a simple math, simple arithmetic math of class 1, 2, 3. What is happening? Yes, anyone? Now see, we have increased water almost 500,000 kilogram per hour. This is a huge amount. This is a huge amount. Now, CO2, complete CO2 is being absorbed, which is total in a gas form, which is total of 15% of 100 kilogram, which is 15 kilogram actually. Now, if 15 kilogram is being injected in a 500,000 kilogram, so what's the percentage you may find in this portion? So percentage is very low in this total quantity. On the other side, if you see on the other side, if let me close this Excel. On the other side, you will see that gas, which is initially at 15% CO2, is now coming without any CO2. Or at least appreciable amount of the CO2 is not visible. Maybe you will find some more figures in the 10th place or 15th place, but we cannot see. So it means when you increase the absorbent, because absorbent is not very poor to absorb the CO2, so you need high quantity of absorbent with the provided or available situations. Now we have to find what is the optimum CO2 value for getting. For example, if I say this is not 500,000, but it is only 5,000. So when we go in a gas out composition, you will see now it is 13% instead of 15 to 13. So it means now it is working. In 1,000 values, it is working. Okay, 10,000. If we increase a little bit more, so I'm expecting 12%, 1% more decrease. So now what is the optimum value of water for this particular case? So you will go in a case study and add particular values. So I'm interested to change the mass flow rate of absorbent column, mass flow of absorbent column, and I want to see that what is the CO2 in gas out. So when I have to see some specific component in a in a stream, so I said this stream and the master composition, mole fraction composition of master composition mole fraction, and in this we have CO2. Now these two things are there. Now if I say I want to change the value of this is 500 to, let's say, 50,000, and uh, with the 500 each time. So if I run, then I have to see. Okay, you will see that when we increase from 500 to 550,000, we reach from 14% in a very straight way to almost beyond below the 8%. Now, if I increase further 500 to 80,000 or 1 lakh, and instead of I said 5,000, so only 20. Okay, instead of 5,000, I says 40 calculations will be performed, and all calculations performed, and now you can see that we decreased from 14% CO2 to 10 to below 2%. Almost now it is in a zero. You can see that final values of the results are in a 1.2%. So in this way, you can converge the absorption column. Now let's have a thorough discussion about the different types and different things of the column. One thing that you can see, here are several other things which are very much interested to see, like profiles, estimates, efficiencies. Okay, so and some other informations like this is a file, this is a volume-based profile, this is a mass profile, and you can calculate anything from here, even estimates. So you can see how from which stage CO2 value is going in which level. Okay, these are not very much interested. We have to see specifications. Now, by default here in these operations, you have to see the degree of freedom. Now, by default, the absorption column has degree of freedom 0. Means no any specification is required to have the calculations. But sometimes you need to add some specifications for instead of a calculation on some predefined manner, you need to define some specifications. ये जो काम है ये डिस्टिलेशन में ज्यादा इम्पोर्टेंट रहेगा या ज्यादा इम्पोर्टेंट होता है एज कम्पेयर एब्जॉर्प्शन, बिकॉज वी हैव टू सॉल्व एब्जॉर्प्शन कॉलम विदाउट adding much specification. What we mean by specification means you want to calculate something on the basis of some other thing. But because here degree of freedom is 0, it means mathematical equations and unknowns are equal. So no any value of any other definition or any other specification. If you want to add, if you want to add, now you have several specifications you can add. Most of these specifications are very much related to the distillation, like cut point, duty ratio, or reflux ratio, reflux rate. So we will see the game of specification in distillation. Now here we are when we say that this is a column, stage column, in which we have a number of stages predefined. So I want to convert this column in a peg bed. So you will find this internals, column internal sign on these columns. When you install any column, I just want to show you this for different things. Like if you install distillation column, so you will find this sample. This sample is called is column internals. Sorry, this sample is called column internals. K sample. Now, when you double click on this internals, you will reach at the column internal. By default, the column internals are stages with some predefined manner. But when you come here, and so it requires to add the column internals. Now you are adding the column internals. Now you have actually added the column internals. So this is CS1 means you are selecting whole section. If you say no, my column internals is up till 10, some another, so you select end stage from 1 to 10, 20, and then you can 8. You might have seen there are columns in which at half up till half different kind of packings are there, and then from half to the upper section, the different kind of packing. So if you have this kind of section, then you can add multiple column internals or sections, and you just change the end stages. But here I'm converting whole section as a one unit, which is from 1 stage to 20 stages. Now here uh, from you can say internal type tray. If you are interested in the tray column, so you can change this number, the tray uh, style or type of tray, bubble cape, or any other type from these options, and number of passes, and you can change the property, and accordingly, it will calculate the respective performance of that particular plate. And if you change the tray from tray to peg, so now it will say that which type of packing, as we have already studied in our books, pal, saddle, metal. You can pick any type of packing, and any further options like diameter. What's the diameter? What's the trace spacing sections? What are the dimensions? Standard dimensions are given. What are the material, whether it is in plastic or metal? So when you select anything, then you will have a special kind of performance. Now you can go in a rating and other things. You can see that how it performed, how gas absorption is performed on the basis of packing. Now instead of sieve, you said pack bed, and now it will give you some more options. Okay, internals, and you one another thing which is uh, you can go in a column environment, and now you are in a column environment, means you are inside the column, and you can see several other special kind of things which are related with the columns, uh, and on the back side you can see the columns as well. Now this is not very much good to see in absorption, but very much interested in distillation, because sometime you need to delete the absorber or reboiler or condenser. So ये वो जगह है जहाँ पर आप आकर ये काम कर सकते हो. So you can see the internals, and import duplicate input interest incomplete. यहाँ पर कुछ आप जो है ना वो like is packing area is 0.2. Now it is complete. Now in view you can see that several design packings and some results by stages. You can select any kind of study, state conditions, and physical properties. It means now whatsoever the packing you have selected and what type of packing you have selected and diameter and other things, its performance is being shown here in a column environment. Now, once you are in a column environment, then you need to go back. Now you need to go back and we have one button to go back. Okay. Um, yes. In the home button, we have go to parent. So actually, we will go back in the main menu where we were. So now when we go in absorption column and we go in column environment, so we are in column environment. But when we want to go back to the parent environment, so we are now here in the parent environment. So this is how you can change their internals, and you can see the performance of this association column. Now, once you alter or you edit any section, now see, I have one another column which is not converged yet, but the difference of internals is from its color. When you set the internals, it turned in a light this blue color. If you have not defined any internals, so no matter, it will not ask anything or anything regarding the internals for the convergence. ये कन्वर्जेंस के लिए इम्पोर्टेंट नहीं होता, ये कन्वर्ज पहले भी हो गया था, हमने इसको कुछ नहीं बताया था, लेकिन only to check the special kind of performance with the special kind of internals like packings, different type of materials, this and that, you need to define this. Even at any moment, you can delete any internal section, and this will not give you any error regarding its overall convergence, but the internal would be deleted, and the things are going on smooth. Now, if you want to practice for this absorption column, I have shared uh, one practical task regarding my old work, and they are also very good. If you go in the practice sheet of this 3, practice sheet 3, sheet 1. So this is actually a detailed description about how CO2 curve is being defined. And in this, you are this practical is basically, again we have to absorb CO2 with the help of polypropylene carbonate, and there is lots of information or required information is given for the conversion, and finally it asks that what is the section diameter, section height, and CO2 composition. So how you see the diameter, to go in a design and in a rating, you will see here it is fixed. Now, once you defined your diameter and packing here, it is fixed, and on the basis of this diameter and spacing, the calculation performs. But when we go in a dynamics, then these things are need to be calculated as well. So at least you must understand that where these things are available means where the design parameters are available, where are the ratings, and where other things are available in the panel. So I think you must try this and then we will have a discussion tomorrow on the absorption column. Should I go with the distillation as well? Very quick demonstration about the distillation column as well. Ji, Kashif Saab.
A couple of questions first.
Okay.
How would you define an iteration?
Sorry.
How would you define an iteration?
Iteration.
Yeah.
Now here iteration. If you are asking about general understanding about the iteration, then once upon a time we studied the subject NACA, numerical analysis. So iteration means the again and again solution of some equation with a little increment in the variable, and we have to see that whether our error is up till mark or not. So this is a general understanding about the iteration. We have gone through all. We all are engineers, so we have studied this NACA subject. Now here in HYSYS, the iterations are not set by ourselves. We have some deep settings of the software as well, that how much iterations or how maximum iterations need to be defined. But subroutines and other functions already written by the developer of the software. We need only to give the appropriate values uh, through which the software actually calculates and give us the results. For example, if I say this absorbent is not good enough, it is 3000, and I said that this gas in is at huge flow rate and at huge pressure, and it is I'm saying that we have only 3 iterations. Now see, it is unconverged. Okay, when I run, okay, तफाक से अभी ऐसा एग्जाम्पल ही नहीं आ रहा जो इसको अनकन्वर्ज कर ले। मैंने आप देखेंगे डिस्टिलेशन में बार बार होगा, when you provide some illogical things to the solver, then you will find it will try to solve again and again, and up till 9999 iterations. After this number 9999, it says that it is not possible. We cannot control the what you call it, the h size, delta h size or other things, but at least we can try to redefine our parameters so that the things will be solved according.
No, but which variables is gonna be varied, and how much the increment or the changing? Who
No,
decides
no, no,
this?
no, no, no. We cannot control the iterations here, like in NACA. We cannot control the mathematics here with any sort of user-defined functions. But what we can do, we if sometime it is not converged, then what we do, we change the parameters. We change the parameters which suits the things for the convergence, and it goes automatically. The convergence are done automatically. If it is not converged, then you will find here red color and it says unconverged. And this situation, because this absorption column is very easy, I tried to unconverge this, and you may find, for example, if this is a gas absorption and it is point 5 and point 5, because here no any specification is defined, so it gave us whatsoever the results are there. यहाँ पर मसला ये है, इस एब्जॉर्प्शन कॉलम में ये भी अनकन्वर्ज होगा आगे चलकर, लेकिन इस वक्त the situation is that because we have not defined any type of specification that okay, we want CO2 at this percent level. So it needs to be converged as it is. For example, if I need to define that, okay, for my column component fraction, I need a specific value of case outlet, and I need CO2, and I said that okay, I need value zero point 0.1 or less molar flow basis. This is a sorry, flow specifying composition flow. No, this is not flow. I am need delete component fraction. Component fraction. Okay, so it is said. I am saying that. I am saying that. Paper and CO2 stream. Yes, stream CO2, and I said that it is zero point 0.1. Now we have added one component, and we have said this should be active. Now it is unconverged. Why unconverged? Because now we have a -1. So we have to say we have to uh, unselect any. Okay, you will find some Naka values here, but we have to unconverged few things. Now, if you see, if you convert this, you will not find any convergence. Current calculated. Now, it says that your specified value is zero point 0.1, but your current calculated value is, which is possible, is 0.4. हम 1% तक नहीं पहुंच पा रहे, बल्कि हम 4%, 10% तक नहीं आ रहे, हम 49% तक ही जा सकते, 50 में से सिर्फ डिक्रीज आ रही है 1% की. So you will have convergence issues in these type of columns. You may have the convergence issues. जब आएंगे तो फिर वो बड़े खतरनाक होंगे, और बार बार हम कोशिश करेंगे कि इनको कन्वर्ट करें. अभी अभी फॉर द टाइम बीइंग it is giving us the as it is result. And convergence is the column is trying to calculate the compositions of and the properties of these two streams. Case out and absorbent out streams are being calculated by the calculations of this column. So iterations are being done on some mathematical equations like Laplace-Clapeyron equation on the background, and it says that what are the possibilities of gas out with their parameters like temperature, pressure, and its particular composition. This composition is very much important. Raoult's law, Henry's law, and phase rule are being solved on the background of this, and their derivative forms. So iteration is required. Yes.
So that means uh, HYSYS does this on its own, and there's no step size or any variable change in the
Okay.
increments.
I have just seen with this deliberation. I have just seen one thing for you people, that errors if you want to select some sort of things, so you can have some sort of things here to guide the solver how to solve this. But if you define your values, then solver will work accordingly, and then some uh, mishap could happen, because their internal settings are very much robust. If you have proper knowledge, then you define. Otherwise, empty values are very much good, because we at least we are getting some convergence. For example, absolute tolerance, if I say it is 0.001, maybe this value is workable, maybe not. So uh, I I say to all of you that at the initial stages, you just play with the software like a kid. Then with the passage of time, you study about the absorption, you study about their proper mathematical equations. फॉर एग्जाम्पल अगर मैं कहूँ सबको कि कौन कौन बंदा जो है वो ये कैलकुलेशंस करके हाइसिस के बगैर कोई बंदा कैलकुलेशन करके मुझे ये पता है कि क्या गैस की आउट कंपोजिशन निकलेगी और लिक्विड की आउटलेट कंपोजिशन क्या निकलेगी. तो हाउ यू कैलकुलेट if you have this information like McCabe method or MTC mass transfer coefficient method or some other fancy method. So if you know those things, then you understand that what is happening behind this call.
Right.
Anything else?
Right. And first
Yes.
you selected in the the graph thing, you selected master component mole fraction. So why not just simple mole fraction?
Yes. Now, when you select any variables, like in our case study, we used to select variables. Now, variables are of two kinds. So one are those variables which are direct. Direct variables means the conditions are direct variables. In the condition page, whatsoever you will see, these are the direct variables. You can pick and choose these variables directly. For example, if I want to pick some another variable, if I want to say that what is the gas outlet temperature, so you can find that temperature is available directly. This is the temperature. But some variables are not direct, like composition of these streams are not direct variables. So they are inserted in the master compositions of different kinds. Like you will find first the master composition. Now there are several kinds of master composition. Master composition mass flow, master composition mass fraction, master composition molar flow, master composition molar fraction, and something. And you will find some triangles inside in front of these variables. So when you say mass fraction and you drop down this triangle, uh, you drop down this triangle, you will find all the components. So to whom you are referring. So for example, I am referring H2. So this is now mole fraction of H2. Mole fraction, when you say mole fraction, so you have to define the particular component for which you are watching the mole fraction. So that's why it is available in mass. So mole fraction, overall stream की mole fraction क्या रहेगी? Anyone? इस स्ट्रीम की ओवरऑल मोल फ्रैक्शन क्या रहेगी? मोल फ्रैक्शन
1.
1. तो वो तो 1 ही रहेगी. तो उसको तो हमने मालूम ही नहीं करना. हाँ, मोल्स मालूम कर सकते हैं, इसके मोलर फ्लो रेट मालूम कर सकते हैं. तो आई एम नॉट इंटरेस्टेड कि कितना मोलर फ्लो इसका मिल रहा है. मैंने ये जानने की कोशिश की कि एब्जॉर्बेंट के फ्लो को बढ़ाएंगे तो गैस आउटलेट जो कि गैस इन का हमें पता है 15% CO2 था, तो 15 से कितना कम हो रहा है. तो इसलिए मैंने इस तरह की स्टडी बनाई एंड यू विल फाइंड के 14% आ रहा था 500 पर. एंड व्हेन वी इंक्रीज द मास फ्लो रेट, ऑलमोस्ट लीनियर trend is being seen, and we got below 2%. फॉर एग्जांपल किसी रिसर्च का जो टाइटल था वो ये था कि हम CO2 को 2% से कम करना चाहते हैं. तो ये ग्राफ शो कर रहा है कि जब आप ऑलमोस्ट 90,000 से बियॉन्ड चले जाओगे, ये 92,000 तक जो है ना, वो जब जाओगे तब जो है वो ये 2% तक आएगा. Okay. Now I think we stop here, and you must try first. अभी हमने वो अपने रूटीन टास्क को नहीं छेड़ा है, but you must try this worksheet of this practice session 3 sheet 1, which I have just shared with you people today. So you must try this so you can understand what is happening. अच्छा, ये जो ट्यूटोरियल बनाए गए थे, ये बहुत पुराने वर्जन में थे. 7.1 शायद वर्जन उस वक्त चलता था हमारे पास. So if you find something fishy, then you just find the appropriate thing in our new versions. होगी नहीं इंशाल्लाह, लेकिन बहरहाल पहले होता था कि उसका ये जो चेंजिंग ट्रे, तो यहाँ पर जैसे लिखा हुआ है गो टू टूल्स एंड यूटिलिटी सेक्शन, स्क्रॉल ऑन, वहां पर थोड़ा डिफरेंट तरीका होता था, एक अच्छा खासा भारी भरकम काम होता था। लेकिन अब उन्होंने ये डायरेक्ट ट्रे सेक्शन दे दी है, तो मैंने ट्रे सेक्शन आपको समझा दिया था कि कैसे करना है। सो इफ यू फाइंड दीज काइंड ऑफ थिंग्स आर चेंजेस, यू विल सी द वीडियो एंड देन मूव अकाउंटिंगली। सिर्फ इस सेक्शन का मतलब ये है कि ट्रेस पैकिंग चेंज करनी है और डिजाइन पैरामीटर हासिल करना है। ठीक है।
Great.
Tomorrow we will see demonstration of distillation column. Then we will again see our routine task. मैंने 3 टास्क आज जो भेजे थे उनको कल हम देखेंगे इंशाल्लाह। कल हम कोशिश करेंगे कि 11:30 बजे तक आ जाएं और फिर थोड़ा बैठेंगे 1.5 घंटे से ऊपर। अगर आप सब लोग विलिंग है तो इट्स ओके, अदरवाइज we will see. Okay. Any further question?
So far, so good.
Okay. Then Allah Hafiz.
Thank you. Thank you. See you again.